Hi everyone. In our previous sessions, we talked about how to quickly select the shortest path of a given um, conduit tree network by picking 3 point in Revit. And we talked about why something can be a little bit tricky when it comes to Dynamo scripts handling a lot of data, and why is it wise to try to compartment things and create multiple custom nodes like I'm doing right now. Um, Now let's dive deep into the main topic of today, the room propagator. So I have used this model in the past where the objectives is to using a annotations and place it in the room and translate that into a called room called view to call a specific place. Um, and now let's take this a step further. So we already placed furnitures inside these rooms. Now I want to propagate that to the rest of the rooms. Let's see this in action again. So I could just go ahead and run. This is exactly the same ideas as before. We're placing a generic annotations inside the rooms, and it is recognizing the the same the room it is in and finding the rest of the same annotation markers and place the same devices in these rooms. It first comes in a little bit tricky all the time for no obvious reasons, but once we run it a couple of times, it will turn to become more realistic and like eventually I've used the color grade out to halftone everything so that um, it will highlight things. For example, if I delete something here or if I move something far away, it doesn't move things within a shorter distance, so I can still attempt to align things a little bit better. But say if I delete things or if I move things way too far and I try to run this again, it will correct them. See, and turn this back to the normal color so that I've realized something has been modified in the script. I could visually check it and control if that is correct. So here's how it is done. We're going to place a marker inside the room that has the furnitures, change the parameter into a unique value, and we're going to select all the other furnitures that has the same that has this script control ID in their project parameter. This is instance text project parameter. I'm going to give it the same name as the annotation layout ID, indicating that they are the things that will be propagated throughout the rooms. And I'm going to check the primary room so that they know that this one is the source. I'm going to place the same marker and rotate it as I want it to be inside the actual rooms, the other actual rooms, uncheck primary rooms to notice that these are the child rooms to use. And there's the flip door so that I can have them to be like a mirrored relationship. For example, I'm putting another one over here. As long as it's inside the rooms, it will recognize it, or even on a different level. Here is good. and then we can run this again. So it will find all the primary room annotation markers and yeah, duplicate the same thing. Again, when it first comes in, the position is a little bit off. Could run this again. See, we'll correct them to some extent. This is still a little bit off, but we can move it by a shorter distance and not trigger the relocation. So we could kind of put them in relatively more making sense positions. And yeah. And then notice the color is different to indicate how things are, how they're following the different parent. And finally, there's the king room. Obviously, it will ignore everything that is not actually inside the room. Oh, I probably didn't, yeah. It will need to be exactly the same. Fortunately, didn't type in the room. So yeah, I guess why is this different from groups? Obviously, there's the ability to have things mirrored, like here. We can use the flip door to control the mirror of things. And also, the more important reason I think is different from a group is that it will read the room boundary and try to place things in the room. So for example, now I'm putting this single room in a larger size rooms, and you see that it is trying to stretch out things a little bit. It will still come in relatively reasonable locations. Therefore, it is actually adapting the size of the rooms, and also like here is showing the orientation of the rooms. That is more interesting and a lot more reliable when it comes to the various types of size of the rooms or the orientation of the rooms, which is I think this propagator is better than just a simple group. Plus there's actually this function where I can move this away, and normally it will reposition it. For example, I can move this sofa away. But say in this particular room, I really want this to be here. I can check the lock movement. So if I run this again, That sofa will move, but not this one because it taken that into consideration. Therefore, overall, I think this is more flexible than the average typical groups that we're using, and therefore is worth developing and really will help me try to place the same amount of furnitures across all of these rooms. Okay, so enough of these basic introductions. Now let's dive a little bit deep into how this is done. I'm going to look at this one. So obviously it's taking a couple of my old examples into incorporate into this one, maybe using the annotation and the rooms to recognize to pair up things, and also we've built the ability to um, snap element to wall. For example, I'm going to place this uh, in here somewhere in this place and have it snap to the wall. Layout ID and give this the same layout ID. Now this time we have a lot various different sizes and shapes of rooms, but yeah, it will still try to place them in the same position and have them snapped to wall at the corner of this room. Sometimes it get to go to the other side, but these are really weird shaped rooms, so hopefully you don't run into them that often. Uh, so how is this done? I guess um, there are two things I find most interesting and I like to talk a little bit more. First is how to find the dot within the different rooms. Uh, we're going to look at a little bit deep into the scripts. Okay, so when we first process any rooms, we are we're dividing these rooms into grid points. Let's turn this on so that it recognizes it. And we're using like numbers to control the amount of grid dots. There is 100 dots in here. I can just increase this to make it more. And then there's also the scripts to offset it a little bit beyond the rooms, because I'm actually dealing with low voltage designs, and part often in case there's comes with say um, room schedulers or card readers that are like not actually inside rooms. So we're going to take a little bit consider something that's slightly away beyond the boundary of the rooms, like that. Plus, this is taking considerate the um, orientation of the rooms. You can see the dots are actually following the shape of the room, and when it comes like that, it has 10 dots on this side, and on the very end side there's also 10 dots. It goes like that. If we feed in all of these rooms, it will look like that. So a smaller rooms has more dense uh, grid dot, and let's change this to 1, so that's slightly away. But a larger room has a wider dot range, so that's how it is controlled. And all of this is using the annotation as the X and Y directions. Right now this is parallel to the wall, but if I do decide to rotate this, you see like these dots will follow the annotation. So that I could slice this room into whatever orientations that I want. In this case, that's 10 dot on this side, and as the room becomes wider, the dot range becomes wider. As the room's smaller, the dots are a little bit dense. When there's openings, it's not going to it's going to ignore the openings. So there's 10 dots on this side. There's 1, 2, 3, 4, 5, and then a huge gap. Then 6, 7, 8, 9, 10. Similar things over here. And even like when there's multiple openings, there's always going to be 10 dots on the side of everything. And that's how it is used to control the room. As a result, I could propagate things regardless of the shape of the rooms or if there's an opening or the size of the rooms. And then say if I place something in here, and let's look at the perceived position point. You can see like this is in the door side of this annotation marker, and in the like left bottom of the room. Therefore, for this one, it's going to be the left bottom, this one the same. And if I choose to go flip door, it will go to the other side. Yeah, actually. And when the room shrinks, because the dot also shrinks, it comes to over there. Let's see if we preview the dot. Okay, so the idea is we have a room and we divide the rooms into different small dots, and then we place the device in the rooms. And here's the location dot. We're going to find the closest 4-point in the source room, in the parent room, and we're going to take the distance between this dot to all those 4 points and take a balanced average and place that into the other children rooms where it is the same index of this 4 dot. So that's how it works. For example, if I place it over here, this will be this is the 8th row between the 8th and the 9th row and the 2nd and 3rd columns. Therefore, if it comes to this children room, it's also going to be somewhere over here. And if I go flip door, it will count the first columns from the other directions, and therefore the second and third columns will come to over here, and the dot will come to here. Therefore, it's going to be the same for like even if we change the size of the rooms. As we increase the size of the rooms, it's still gonna be the same index number and the same average. So it's always going to be that bottom left or right corners. And it's the same reason we'll try to avoid an empty. If I put it somewhere here, even though in this case it falls into the circles, the empty circles, but because this rooms it don't have dot in the center, we'll place the dot somewhere in here. And that's the main tricks in this process. Once we have the dot, we can place the families and say matching the parameters, snap them to wall, color override. They're all straightforward. But the first step is worth talking about is to place the dot. And during the placement of dot, again, we're using the elevation markers as the X and Y's. it is very similar as what we did before in this one. So we're taking a rooms and we're giving it different x and y's, and we're using that as the new bounding box to calculate the room. The similar goes to here. If I feed in this, I'm using these rooms, but now let's pause this here first. Even though the room is in a weird shape, it is taking this annotation markers and its orientations to calculate the new shape around it. And we'll be drawing lines and for each of these lines we take what has been intersecting with the rooms, and then using this line to divide that into 10 dots. Therefore, if we change this to automatic and see, like, it is the similar process. It's slicing that and dividing this into different dots. Well, it's actually the other way. So yeah, it's drawing lines in this direction, and once it's cut in there, it's dividing this cutted line into 10 individual segments. And if it is coming to like this kind of rooms, the same way goes to here. It will have a line cutting through. But this time it's divided the line into 1, 2, 3, 4 segments. And using this, combine this 4 segment and still calculate 10 dots to complete this grid. So yeah, there's the grid, and after the grid, there's the dot. If we're looking at this flow, yeah, we talk about match the room with the annotations, and then using the annotations X and Y to calculate the grid dot, and from the source element location, calculate the target location with the same grid index. This is the basic steps, and check the preview. Next step about this thing is um, because as you have seen from the example, it actually has the ability to recognize uh, if the element has already been placed. Well, you can see like it's trying to place the same circles around the different rooms. And for larger rooms, that's larger circles. For different shape of rooms, the circle has been pushed into different um, orientations. And this one is kind of squished over there. It is because like each of these element has been given a specific ID that start with the layout ID is the annotation markers, single rooms or queen rooms, and then there's the room number indicating which room it is in, and finally the element ID, which is the source element it has. Therefore, we can close this from here now. Once we run this, it will create all these elements and give them this unique ID. Each time the script is running, it is uh, calculating all the IDs that should exist and is checking that if there are other IDs that shouldn't be there. So here I delete a room and I delete a marker and I delete a couple element. So next time it runs, it will realize that this room no longer has a matching ID, matching annotations. So the room's ID shouldn't be included. And this one, the annotation is no longer inside the room. So the annotation should not be included. If I run this again, it will recognize like all of these elements, even though it has an ID, it is useless, therefore should be deleted. And all of these elements that we just deleted, there is no device with the same element ID, therefore it should be created. That's the second part of this. Comparing all existing elements, decide if something should be delete, decide if something should be create, and then compare the positions of them versus the calculated point. Like if it's too far away, we will move them back, basically. Yeah, it moves them back. But this blue dot is becoming a little bit annoying. Let's just close this and start again. And for the last part, all the moved element will match the source rotation, and depending on the settings, it will snap to the wall. And for all of these elements, the existing element no need to move, and all those process element will match the type instance and parameters. Finally, the color override. So for example, let's demonstrate this a little bit more. I could place a couple of these in here. Well, 2 is fine. The script is reading the family name to decide whether this need to snap to wall. So if I delete the wall in the family name, the outlet will no longer snap to wall, but the card reader will still snap to wall. So if I run that here, oh, because this is not included. Those ones will get snapped to wall because it's like closer to wall, and these two will be left just untouched. Okay. What else should we talk about? The other topic, the second interesting thing, is how this I've run into this little bug, mostly because I realized that things are a little bit different from how I see it works when there are multiple um, multiple parent views to start with. Let's try it in this room then. So we just delete all of these placed elements, and if we run this again, this time it's going to find multiple rooms that both need to create element. And notice like here is obviously missing stuff, and here the single room is also missing the bed, and also like here. Basically, I realized that whenever it's processing multiple creations all at once, it is kind of buggy, and it will be helpful if we run multiple times. It will eventually comes up, right? Like now there's coming up. Now the single rooms comes up back up again. But that's kind of buggy, and I never figure out what exactly is the reason. So that's why I create this color override thing to like highlight the processed element and halftone the existing created element, so that we can see as things progresses how it is changing from time to time. The idea is run this continuously eventually, when everything becomes half-toned, we know that um, the script has done its job, place things as best as it can. The left job is for like humans to start moving things around to make them more realistic. Yeah, pretty much that's it. And eventually, there's two remaining things I want to add, which is have things oriented to the door and have things oriented based on the existing placed element. So the reason I have this lock move check parameters created is mostly because um, we have, say, card readers. They are focused around the doors. And even though we have this annotation markers, which will indicate doors somewhere over here, or it is somewhere over here. But realistic is door can be on this wall as well. So we could have, I don't even know if we have doors. Yeah, we can have doors on here, or on here, or on here, or even on top of this room. The the things we want to place should actually be located oriented based on the door instead of the rooms. And also sometimes we always want a fixed distance between the bed and the table desk. But if say these rooms get really wide, that relationship will become tricky. Let's see if we can, if I can move this. Yeah, probably not like that. Now I made a really huge rooms. Um, yeah, everything is kind of widely scattered, but in reality, I still want these two things to keep a given distance, not to be too far away from each other. That's where things should be based on given fixed distance instead of just placed around evenly across the rooms. Although we really don't run into this kind of situation all that much, it's still good to have. So maybe in the future we'll add these two functionalities and make another video for part 3. But this is pretty much as far as I think the script approach of room layout will go. If we want to dive in deeper, the work comes to like machine learning aspects where we have to train the software to think differently instead of we specifically tell it where to go. Then that will be a completely different topics for a completely different times. But for now, this is how the room propagator works. Thank you. That will be all for today.